All right, here we are dealing with an ODE, ordinary differential equation, and we have x to the third y double prime plus x squared y prime minus 4xy equals 1 plus x times cosine of ln x. Okay, so the first thing that we should notice is that we do not have constant coefficients. Now, for this one, as a heads up, I'm going to tell you what we're going to be using. We're going to be using first Euler Cauchy method, and then we're going to finish it off by the undetermined coefficient method. Okay, so first up, let's start with Euler Cauchy. We're going to use x equals e to the t. Okay, so we're going to use this to help us convert this Euler Cauchy equation into an equation that is with constant coefficient, and it's a simple linear ODE. So that's gonna help us simplify our work a lot. Okay, so let's go ahead and work this. First up, let's solve the other way too. T equals ln of x. So from here we solved it. Now let's go ahead and work on our first derivative of y, dy over dx. Let's find this one. Since we're turning this whole equation into an equation that's gonna be our variable, we're gonna be having t, okay? No more x's, okay? Since we got rid of it, now we're gonna have to be doing all these, and we have to end up with something that has only t in it. We have to substitute all our x's out. So let's start with the derivative of y with respect to x, but we're gonna change it dy over dt, dx over dt. Just basically divide the top and the bottom with dt. That's gonna give you this, dy dt times dt dx. Now this one we're gonna mark as y dot, and here dt dx, we can go ahead and that will be the derivative of this guy right here, t dt right here with respect to x, because we're working with x. So that's gonna come down, and from here you can follow how did I do it. It's simply the derivative, and it's gonna give me 1 over x. So I'm gonna substitute these two back in. There you have it. But 1 over x, we have an x. We don't want x's, right? So let's substitute it out with e to the t. There it is, 1 over e to the t, which is y dot times e to the negative t. Now our equation has second order derivatives as well, so we're gonna find our second order too. So the second order derivative of y with respect to x, here you can see me using the chain rule and substituting everything as I go. Again, we don't want to be left with anything x, okay? So we're gonna get rid of all of those. So here we found that dy dx, it was right here. Plug it in. ddt stays. So we're going to take a ddt of this parentheses, and this is just simply multiplying this whole thing. And that is dt dx, which is right here, 1 over x. So plug it in. Here, this is just simply the chain rule for derivatives. That's how we come from here to here. Now, after this step, I'm going to convert this one again, plug in e to the t instead of the x. We don't want x's right here. And this is what we have. Now, this one is just multiplying, but let's take care of this derivative. It's the product rule. That's what you see right here. Take care of it right here. We're going to get y double derivative times e to the negative t minus y to the derivative, first derivative, times e to the negative t. And the e to the negative t at the end is just multiplying. Simplify it, we're going to multiply this in, then from here we're going to factor it out, and we get this final form of e to the negative 2t, parentheses, y double prime, let's say double dot, minus y derivative. Now we got these, and these in order so we can plug into our original equation and get rid of all our x's, right? And through this process we're also gonna obtain constant coefficients. So that's what I'm going to do next. I'm plugging in this, and this into my ODE. That's what we see down here. Here we had x to the third, so my x is e to the t. We're gonna substitute it out. My y double prime we found right here, basically what we just found a minute ago, plus x to the square, my x substituted out. This is my y prime plugged in from what we found, minus 4xy, sub out our x, equals 1 plus, in this side too, get rid of the x's. So this was x, plug in e to the t, cosine ln of e to the t, because we had an x there. Let's go ahead and simplify. All I did is collect all the e to the t's, add them up, add the exponents up, and we can see right here. Now let's make it even simpler by getting rid of e to the t by multiplying with the whole equation with 1 over e to the t. So all our e to the t's are done except here, the 1. We didn't have an e to the t to simplify, so all we're gonna have is 1 over e to the t, which is e to the negative t. These two will simplify out, so all we have is this, y double dot minus y, simple, no derivative, equals e to the negative t plus cosine t. Now there you have it. This one is a constant coefficient linear ODE, second order. Alright, and this one we should be having a little bit less issues solving than the one we started with. Now, since on the right side we have e to the some power and the cosine, these two will allow me to use the method of undetermined coefficients. So when we have a polynomial, e to the power, cosine, sine, these we can guess what we do, what we put on this side, right? And we're gonna have just an undetermined coefficient in front, which we have to solve for. So that's what we're doing here. First, the homogeneous equation, we simply ignore the right side, equal to 0, right here. Characteristic equation is r squared minus 4 equals 0. Make sure you don't accidentally put an r here just because there's a y there. So this will give me r equals plus minus 2. This will give me the two solutions for the homogeneous equation, and right here yh is equal c1 e to the 2t plus c2 e to the negative 2t. Okay, that's our homogeneous equation. Now let's work on our yp, the particular solution. So for the undetermined coefficient method, we usually can use, there's a table like this in almost every differential equation book where we can select what we guess. So if we have a polynomial, we guess this. If we have a e to the some exponent, we guess this. We have combinations of polynomial e's and sinusoids, then we guess this. Okay, so that's what's coming here. This is what on my right hand side I have two terms, so I'm gonna guess 1 g1t equals e to the negative t. This is my first term, and for this guy I'm guessing a solution of a e to the negative t, and for my second term g2t is cosine t, this one, I'm gonna guess a solution for it, which is b1 cosine t plus b2 sine t. Okay, let's work on the first one, y1, a e negative t. Okay, that's my first one. I'm gonna go ahead and find my first derivative for it and the second one. After this, we're gonna take our result and plug it back into our equation. Be careful, don't go and plug it into the original equation, okay? We're gonna plug it into this one, the one we are working right now. We are not working with the original one with the not constant coefficients, okay? So come back and plug into this one right here. That's what you see. And from here we can see that the only unknown basically is the a, since we can cancel out our e to the negative t right here. We're gonna have a equals negative 1/3. Therefore my y1 solution is negative 1/3 e to the negative t. From here I'm gonna plug this guy into this one, and there's my first particular solution. Now my y2, we said we're gonna guess this for it, b1 cosine t plus b2 sine t. Same thing, I'm gonna go ahead and find my first derivative, my second derivative, there they are. And now let's go ahead, plug back into our ODE. Here it is, my y double prime from here, plug it in, minus 4y, which is that one, plug it in, equals only the part that we are working with right now, cosine t. Okay, let's simplify. Here you have it. Collect the like terms, the cosines, put them together, sines, put them together, and basically simply comparing the left hand side to the right hand side, we can see that we have cosines and cosines. Let's match them up. Then we have sines, and we have sines, but basically times 0. So that's what I wrote here. We're gonna cancel the cosines here, so we're gonna find that b1 is 1 over negative 5, and here we can see that b2 is simply 0. From here, let's plug it back into our y2, our original guess, and we can see that y2 is negative cosine t over 5. Now here it is, our solution for with all our components, which is homogeneous plus particular. So it's c1 e to the 2t plus c2 e to the negative 2t minus 1/3 e to the negative t minus 1/5 cosine t. Now be careful, make sure you don't accidentally forget and think that we're done. We didn't start this problem with t's in it, we started with x's, so we have to go back and convert it back to x. There it is, that's what you see right here. Substitute x back in, and remember our x was our t was equal to ln x here in the beginning when we substituted in. And now simply plug it back in. Everywhere you see a t, put ln x. Clean it up, simplify, and here's our final solution, which is c1x to the square plus c2x to the negative 2 minus 1/3 x to the negative 1 minus 1/5 cosine of ln x. And there you have it. That's our solution. Thank you for watching. Please subscribe and give a like to the video so other people can find it as well. Thank you.